Hey, Professor Capps, it's Michael James here doing the electron domain geometry interactive assignment. So what I'm going to do for this video is I'm going to pause intermittently as I construct off camera the different types of electron domain geometries, just for the simplicity of not having to blow up like 48 different balloons. I originally was going to do that idea, however, I thought it would be best to keep the colors consistent, and when I went out to get my balloons, I didn't realize that they were all different colors, so I kind of wanted to keep that kind of fluid. All right, so I'll get started with my first one, which is the trigonal planar electron domain geometry. It's going to be a type of molecule AB2. It's got 3 different electron domains. So when we look at my balloon configuration here, throughout the course of this video, the blue, the larger balloon, is going to be my element, and the white balloons attached to it will be my electron domains. So, like I said, this is trigonal planar. It's got one lone pair, and the placement of the lone pair is going to be up here at the top. Sorry, the one that I'm pointing to right here. And it's usually going to have a bent configuration. So, think of it kind of like up and then down. And then an example of this would be SO2. All right, I am back now with the AB subscript 3 type of molecule. We've got 4 total electron domains here. 1, 2, 3, and then 1 on the top. This is going to be a tetrahedral electron domain geometry with 1 lone pair. So in this configuration, the lone pair is going to be the one that's located up here, and it's got a trigonal pyramidal molecular geometry with NH3 as an example molecule. This next configuration is an AB subscript 2 configuration, kind of similar to the one I previously discussed. It's got 4 different electron domains up here. The difference being with this one is that we have 2 sets of lone pairs. So these 2 would be our lone pairs, giving a bent molecular geometry shape. An example of this would be water, which is H2O. All right, so this next configuration has a molecular of AB subscript 4. It's got 5 different electron domains, and the shape is trigonal bipyramidal. It's got 1 lone pair, which would be this electron body over here. It generally has a seesaw shape. An example would be SF4. All right, so this next one is AB subscript 3. It has 5 different electron domains, trigonal bipyramidal shape, and then it has 2 different electron bodies, and it's often T-shaped. So if you're looking at this one, imagine that this up here, this down here, and this one right here are your electron domains that are not lone pairs, and then this one and this one would be your 2 that are lone pairs. And an example of this molecule is ClF3. So this one is AB subscript 2, 5 electron domains, 3 different lone pairs, very similar to the previous ones that we've discussed. It's got a geometry of trigonal bipyramidal. The difference being that it has 3 lone pairs and it's linear. So imagine, let me tilt this the right way. So this one down here and this one up here are the electron domains that are not lone pairs, and then the other 3 are the ones that are lone pairs. And an example of this one is IF2 minus. All right, so this one has 6 different electron domains. Its configuration is AB subscript 5. It's got an octahedral geometry. If you notice, we got 1, 2, 3, 4, 5, 6 different electron domains. There is 1 lone pair, and it usually has a shape of square pyramidal. An example would be BRF5. And then finally, we have AB subscript 4, 6 electron domains, octahedral geometry. Similar to the previous one, except this one has 2 sets of lone pairs. with a square planar shape. So imagine 1, 2, 3, 4 electron domains that are not lone pairs, and then these other ones on the backside, and this one over here would be the lone pairs. And an example of this one is XeF4. All right, thank you very much.